In this video, I'm going to show you how to complete the nomenclature worksheet. And to do that, I'm going to use something that you could find on this page. It's called the Ionic Covalent Compound Naming Flowchart Document. And I have that up on my computer in a PDF format. And I'll walk you through how to use this as I go through some of the nomenclature, we'll say, problems in the worksheet. I'll start by noting there are videos included in Canvas that describe thoroughly how to identify ionic and covalent compounds, and videos specifically on how to name compounds with lots of detail. And some of the detail is included in this flowchart, and I will bring up again in this video. But this video primarily is to show you how to use the flowchart and to complete nomenclature worksheet. So let's get started. So the first thing we need to do is determine if a formula represents an ionic or covalent compound. Well, this first page on the worksheet, it says here these are all ionic. Well, let's just verify that these formulas represent all ionic compounds. Okay, so things to observe. Well, let's see, covalent, the formula begins with a nonmetal other than NH4. All these formulas begin with a metal. We could verify that, yeah, these are all not covalent, they're all ionic. So we're going to move over to the right here. So things to observe. The formula begins with a metal or NH4. Turns out that none of these begin with NH4. There's one formula on the last page that begins with NH4. So parentheses around NH4 indicate 2 or more NH4 units. Okay, we don't have that case on this first page, but that's good to know. All that follows the metal or NH4 is the anion. So you need to know that ionic compounds have a cation and an anion, and this is explained in detail in another video. So parentheses around the anion indicate 2 or more polyatomic anion units. For example, TCNO3. NO3 is a polyatomic ion, and there's more than one NO3 polyatomic ion unit, and there's 3 of them because that 3 is outside of the parentheses. So all these little details you want to pay attention to. Before we move to the next step, let's just go through this and say, all right, yeah, let's identify the 2 components, the cation component and the anion component. So I'm going to put a circle around the cation. In this case, it's a metal, and then a rectangle or square, a quadrilateral, whatever, around the rest of the formula, which is the anion. Over here, here's the cation, and I'm only going to put what is inside the parentheses in this rectangle. All right, remember the parentheses indicates 2 or more polyatomic ion units. And down here, I summarize a lot of stuff I'm going to explain in detail. Okay, like for example, parentheses indicate more than 1 polyatomic ion. All right, so how many polyatomic ions are there? There's 3. Here, there's the cation, the metal, and then there's the monatomic anion, and there's 6 of them. Here, there's 3 monatomic cations, and then 1 polyatomic anion. So why is it only 1? Because there's no parentheses. All right, so you'd be real careful about this detail. So that 3 right there is part of the polyatomic ion formula. So how am I supposed to know what the formulas of polyatomic ions are? Well, kind of explain that in another video, but real quickly, I'll scroll down to the last page here. So on the last page of this worksheet, there's a list, an abbreviated list of polyatomic ions. Of course, you could Google a list of polyatomic ions. So you learn how to name these polyatomic ions by looking at that polyatomic ion list. So we'll just finish this off here. So this is the 1 polyatomic ion. Here is the 1 metal cation. Here are 2 polyatomic ions, 8CO3. Here are 2 cations, 3 monatomic sulfide ions, and let's see, 2 sodiums, 1 oxide. Here's a fun one: 2 silver cations and 1 polyatomic anion. Here is one with 2 lithiums and that same polyatomic anion. We're going to write the formula for the strontium cation. So you write Sr and with the charge, and there is 1 of the strontium, and the anion is the sulfide, and there's 1 of those. Okay, so as far as naming goes, let's see. Let's go back to the flow chart. The cation, we're right here at this point. The cation, or is the cation NH4? And the answer is no. Okay. So the next question is the metal from group 1A or 2A in the periodic table? Or is the metal cation silver, cadmium, nickel, zinc, or aluminum? And it turns out that strontium is in group 2A. Okay, so we answer yes. So you go down here and it says no Roman numeral is required in the name. Okay, so then you just go and A and you just name the compound. So this one is simply strontium sulfide with no Roman numeral. And I'm going to try to fit this over here. The next one, the cation is Tc, and we're going to write Tc here. Now the charge, we have to figure this out, do a little bit of math. And I explain this in detail in the ionic compound nomenclature video. See, we have 3 nitrates, and I know it's nitrate because it's listed in the polyatomic ion list. And so there's 3 of them. The total charge contribution of the 3 nitrates is -3. Okay, the 1 technetium, the charge of the 1 technetium, and the total charge from the nitrates must sum up to 0. So I'm going to call or label the charge on the technetium X. So that charge on the technetium plus the charge from the nitrates, it's -3, this has to equal 0. So you have a little bit of algebra problem here. So obviously this X has got to be +3. So the charge on the technetium is 3 plus, or +3. And there is 1 of these technetium cations, and there are 3 nitrate ions. So this is a technetium nitrate compound. Now, do we need a Roman numeral? Let's go back over here. Is the metal from group 1A or 2A? No, technetium's not. Is Tc one of these 5? No, it's not. So Tc is not in group 1A or 2A, and it's not one of these 5. So that means we need a Roman numeral in the name of the compound. So it is a technetium nitrate, but it's a technetium 3 nitrate. Remember from the video I made on naming ionic compounds, the Roman numeral is the charge on the metal cation. This one here is technetium 3, and I'm not going to fit this, but nitrate, etc. Finish the rest of it. This next one is chromium, is the metal cation, and we have a monatomic anion, and this is fluoride. So this is some kind of chromium fluoride. I'm going to lay out the ions in a moment, but let's first see if we need a Roman numeral. Chromium is not in group 1A or 2A, and it is not one of these 5, of course. So we do need a Roman numeral. The question is, what's the charge on the chromium? And that will be the Roman numeral that we need to include in the name. Let's see, Cr is the cation, and there's 1 of them. Fluoride is the anion, and there's 6 of them. Doing a little math, we have 6 fluorides, so this contributes a -6. So the question is, what's the charge on this 1 chromium? So we'll call that X. So X plus a -6 must equal 0. So X is positive 6. So that's, we write in chemistry 6 plus, not plus 6. The name of this one is chromium 6 fluoride. I won't get it all in here, but I'll get the Roman numeral in here. And this is fluoride, F-L-U-O-R-I-D-E. Maybe I did get it. Okay. So the next one has 3 potassiums, and potassium is a +1 metal, and there's 3 of these guys here. The anion is PO3. Turns out that PO3 is in your polyatomic ion list, and this is a -3 or 3 negative charge. There's one of them. So this one's pretty simple. This is simply potassium phosphite. We don't need a Roman numeral because potassium is in group 1. So here's the case where the metal is in group 1A, and so we proceed and no Roman numeral is required. We answer yes to that question, and we just name the compound. So this one's potassium phosphite. Let's see, the next one here is a zirconium compound, and there's 1 zirconium, and there are 2 polyatomic ions here. This is bicarbonate or hydrogen carbonate, and so this guy is written like that. So I want you to figure out what the charge is on the zirconium. Knowing that there's 2 bicarbonates and each one is -1, you could do the math. So this contributes a total of -2. There's 1 zirconium. So what does the charge have to be on the zirconium? It has to be positive, of course. And you do need a Roman numeral because zirconium is not in group 1A or 2A, and it's not one of the 5. So this is some zirconium bicarbonate with a Roman numeral. And the Roman numeral, again, is what the charge is on the zirconium. I'm going to jump down here to this guy here. So here's a fun one where there's a metal in the polyatomic anion. Cation is silver, and silver is a +1. How do I know that? Because it's written in this document a couple places. So Ag +1, and there's 2 of them. And the anion, you'll find this on the polyatomic ion list, is dichromate, and there's 1 of them. There's no parentheses here. There's not 7 of them. There's no parentheses because that means there's only 1. Remember down here, parentheses indicate more than 1 polyatomic ion. There's no parentheses here, so you got 1. This one is silver dichromate. No Roman numeral needed because silver is one of these 5. So let's go here. Is the metal from group 1A or 2A? No, but it is one of the 5 listed here. So the answer to the question is yes, it is part of this little group. So you proceed and name it without a Roman numeral. So this is silver dichromate. And by the way, over here I kind of summarize some of the things. You know, like group 1A and 2A are +1, +2, guaranteed. As far as the metals go, here is the list of 5 metals that are guaranteed charges. So if your metal cation is not, just like what the question here asks, if it's not in group 1A or 2A, one of these 5, you need a Roman numeral. The last page, because the second page is super easy. The second page is all covalent compounds, and that's a no-brainer. You could name those real easy. Don't use common names, by the way. You know, use systematic names. So on this last page, the third page, first you need to identify if the formula represents an ionic or covalent compound. Just to give you a hint, there's only 5 covalent compounds listed here. So you're going to have 5 C's. Okay, like this one here is a covalent compound because it starts with a non-metal. This is a metal, this is a metal, this is a metal, 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 metal. Oh, look at this, NH4. Okay, this one starts with NH4. So this is that one exception to, the metal, non-metal rule for ionic. So this one's an ionic, by the way. Now I'll let you find the other 4 C's. I'll do like one on this page here. Let's do this one here. This is ionic, of course, because it starts with metal, with iron. And so this one is an iron nitrate. Okay, so we're going to start with that. Iron nitrate. Now we're going to need a Roman numeral because iron, Fe, is not in group 1A or 2A, and it's not one of these 5. So now the question is, what's the charge on the nitrate? Well, there's 3 nitrates, and they contribute a total of -3. And so this one iron must be +3, so the Roman numeral is 3. So it's iron 3 nitrate. And I'll do one more. This one here. This is ionic because it begins with manganese. And I'm going to break this down here off to the right. So there's 2 Mn's, and I'm going to put X here as the charge on each of the Mn's. And the SO3 is sulfite. You'll see that on your polyatomic ion list that sulfite is -2, or 2 negative. So this contributes a total of -6. Well, we have 2 Mn's, so I'm going to represent the total charge contributed by the Mn's as 2x. So the 2x total positive charge plus this -6 must sum up to 0. So if you could see that this is 3, great. If not, do a little bit of math here and bring the -6 over to the other side. Now it's +6, divide both sides by 2. So X is 3, +3. So the charge on each of the manganese ions is 3. So the name of this compound, and I'm going to put it right up here, is it's not magnesium, it's Mn, manganese. Manganese 3 sulfite. Okay, enjoy completing the rest of the worksheet.